Welcome back to the second part of the lesson where we're talking about truth tables and logic diagrams. You should know all about the logic gates, not, and or. And this time we're going to talk about logic circuit diagram. So let's do that. What you need to do is we know about the three logic gates, and, or, and not, but if you combine those together, you can make a logic circuit. All the operations that you now perform using those logic gates is part of that logic circuit, also known as a logic diagram. So a key term for you is logic circuit, also known as a logic diagram, a combination of logic gates that together create a circuit. We know about logic statements, so here's one a little bit more complex than you're probably used to. We're saying here that the single output, well actually let's ask you a question. How many inputs do you think there are? And how many logic gates are there? We know there's a single output X. But how many logic gates are there? Hopefully you can see there's 1, 2, and there's two inputs, A and B. And what will happen is the output of the OR gate, because it's in brackets, which happens because it happens first, will flow into the NOT gate. So the logic circuit, if we put those together, those two logic gates, it looks like that. You have your OR first of all, A and B, and then whatever comes out of that flows into the NOT gate. So A or B first flows into NOT gate to give you the output X. Truth table for that, A or B. Remember, OR is like addition, so nothing and nothing is nothing, but the output says there's 1. Why is that? Well, because we're knotting it. So if nothing and nothing is 0, what's not 0? It's a 1. Right? Or these two together, 0 and 1, 0 plus 1 is 1. But what's not 1? Not 1 is 0, and that's how you do this. 1 and 0 is 1. If you OR it, but then you knot it, that becomes 0. And 1 and 1 is 1, but if you knot 1, it becomes 0. Let's look at another one. X equals not A and B. Well, how many gates, how many inputs are there? Well, you can see there's two inputs, A and B. And how many gates are there? Well, there's not and, so those are the two gates. Looks like you're going to do a NOT of the input A first, and then that will flow into an AND gate along with the input B. So the circuit will look like this. Do the NOT A first, so here's your input A, getting knotted, excuse my French. It goes through into the AND gate with the input B. What does the truth table look like? Well, we're going to NOT A before we do this AND. So what's not 0? It's 1. What's 1 and 0? It's 0. What's not 0? It's a 1. What's 1 and 1? So 1's like multiplication, remember? 1 times 1 is 1. What's not 1? It's a 0. So what's 0 times 0? 0 and 0 is a 0. And what's not 1? 0. 0 times 1. 0 ANDed to 1 is a 0. Keep on going. We've got this one here. How many inputs in this one? How many gates on this one? Well, we know there's AND gates, OR gates, two AND gates in fact, and there's A, B, and C, so there's 3 inputs. That OR gate is a good place to start actually, because we know that OR is like the central point, and output from the AND going to go into the OR, so the OR separates those two parts of the statement, and then whatever flows out of A and B is one input of OR, and whatever flows out of B and C is the another input of OR, and then whatever comes out of the OR is the output for X. So you'll need one AND gate for the inputs A and B, one AND gate for the inputs B and C, so your logic circuit's going to look like this. Here's your OR, which is taking whatever comes out of A and B. So A and B, here's the AND, there's A and B, that's a little separator there, and then AND B and C. So A and B is this one, and they'll come out and go towards the OR, that's this bit here, and then B and C is this bit here, which comes out and goes into the OR. And you'll see this a few times where an input might get split, because it might be used by more than one logic gate. So remember, the inputs A and B flow into the first AND gate, they the inputs B and C come out of the second AND gate. Both of those then, both the two outputs, got here both the two puts from these gates, but you know what I mean. And the output from the OR is the X. We said about that, right. What about a truth table? Well, we've got 3 inputs now, A, B, and C. So you're going to have, counting up from binary, 0, 0, 0, all the way up to 1, 1, 1. So from 0 to 7, you're going to have 8 different values. Also, to make things a bit simpler, is when you do A and B, call the output of that another letter, just so it makes it easier to work with later on. So A and B, the output you could be D and B and add another column. And that's what we'll do. We'll call it D and E. And the truth table will look like this. So we've got A and B here, and whatever the output of that is from the AND, we're going to put into this column D. So A and B, column D, and then the outputs from the ANDs of B and C is going to be E. And then we'll OR these D or E's together to get us X. And that's known as a working output. The working output D is A and B, and the working output E, B and C. Let's take the first line as an example here. A and B, we AND those together, that gets you the working output D, and B and C ANDed together gets you the working output 0, and then if you OR 0 and 0, you get a 0. Alright, let's take the fourth line. A and B ANDed together, remember AND's like multiplication, so 0 times 1 is 0. And then B and C ANDed together, the 1 and the 1, is a 1. And then we OR these, the D and the E. 0 or 1 is a 1. Look, the best way of doing this is trying it for yourself. So have a go. Try those 3, pause the video, and I'll show you the answers in a sec. Welcome back. So here's the first one. We're saying X, not A and B. So A and B we're going to do first. So let's get that AND gate, A and B. That'll get us A and B. Whatever comes out of that is going to flow into the NOT. So we need a NOT gate now. Well, actually, I've got a working output there, C. But it goes into the NOT, and that gives you X. What's the truth table look like? A and B. Look how we can count up in binary. 0, 1, 2, 3. So we haven't missed anything. And then working output C is A and B. So AND is like multiplication. So 0 times 0 is 0. 0 times 1 is 0. 1 times nothing is nothing. And 1 times 1 is 1. And then we're going to NOT C, which is knotting A and B. So that's why I don't even have to look at A and B anymore. I can just knot this column here. So not nothing is 1. Not 0 is 1. If it's not 0, it's 1. If it's not 1, it's 0. Done. Look at the next one. X equals A or not B. Now, not B is in brackets. So let's get a NOT gate out and not B. Like that. Let's call the working output for that C. And then what's happening? That's flowing into an OR gate with A. So there's your OR gate. There's A. And we're taking that output and going into here, and that'll give us X. So what does the table look like? Again, counting up in binary, 0, 1, 2, 3. First one, the working output was not B. So what's not B? So what's not 0? 1. What's not 1? 0. What's not 0? 1. And what's not 1? 0. Then that output, C, which is this column here, is going to be ORed with A. So A and C together are going to give us this column. So OR being like addition, 0 plus 1 is 1. 0 plus 0 is nothing. 1 plus 1 is 1. And 1 plus 0 is 1. Right, then the hardest one. A or B and B and not C. You could start with the A and B first. You could start with the not C. I'm going to start the one with in the most amount of brackets. So this is within not C here is within a bracket already. So I'm going to do not C first. So not C, working output of D. And because we're in this bracket, you might as well now AND whatever comes out of that along with B. And that's here. So there's the AND gate. So whatever comes out is coming out with B. And a working output for whatever that comes out of these two inputs, I'm going to call E. So that means we've done this side of it. Let's pop now to the other side of the AND and do A or B. So let's get an A or B going on. See, I've done a little split there. Whatever comes out of that, I'm calling F. And then so the output of that and the output of that should then go in with an AND. That's the AND. And the truth table for that is quite a wide one. So first working output here was D, where it was not C. So D is not C. So what's not C? So what's not 0, 1? What's not 1, 0, 1, 0, 1, 0, 1, 0. Next working output was E, where we were taking column D and combining it with B. And that was going to be an AND. So column D and B. So 0 and 1 is 0. 0 and 0 is 0. 1 and 1. 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. And 1 and 0 is 0. Next was this one up here, F, where we were going with A or B. A or B. So 0 or 0, 0. 0 or 0 is 0. 0 or 1 is a 1. 0 or 1 is a 1. 1 or 0 is a 1. 1 or 0 is a 1. 1 or 1 is a 1. And 1 or 1 is a 1. And that means we've now got E and F going into an AND. So column E and column F going into an AND. So just AND these two columns together. So 0 and 0 is 0. 0 times 0 is 0. 1 times 1 is 1. 0 times 1 is 0. 0 times 1 is 0. 0 times 1 is 0. 1 times 1 is 1. And 0 times 1 is 0. Easy if you know how, right? So those are 3 questions done. Your turn, Edmodo. Have a go at that. You'll need to look at the diagrams. Need to get a pen and paper maybe to work it out there. You've got 60 minutes to do that, so you've got way longer than you'd really get in an exam. Have a go at that. Assuming you've done that, that's us done with this part of these 2 lessons, truth tables and logic diagrams. You should know about logic gates now, not, and, or. You should know about truth tables, logic circuits, logic circuit diagrams, be able to create these tables. We should be able to create diagrams, but it's a bit hard to do from remote learning, so we will be doing that in class when I get hold of you. For GCSE, you will be required to make your own diagrams, but for now you should be able to interpret these and have a good idea how to make them. So hopefully now you know about voltage, logic gates, microprocessors, logic statements, truth tables, logic circuits, or logic diagrams. Great. Thanks. Cheers. Bye-bye.